Have you ever wondered what keeps the world alive? From the tiniest blade of grass to the mightiest ocean currents, it all starts with one thing: the sun. The sun is our ultimate energy source. It gives Earth warmth, light, and energy. Everything that's needed for life to exist. Without it, our planet would be a frozen, lifeless rock just drifting in space. Think about it. Without the sun, we wouldn't have any degree of warmth at all. We'd have a little bit of geothermic activity, but nothing from the outside. It would all be much, much colder than the Arctic or Antarctic. Some basic facts about the sun. The sun is enormous. It's about 1.4 million kilometers in diameter. That's about 109 times wider than the Earth. And it sits roughly 93 million miles away from us. And at its core, the temperatures soar to nearly 15 million degrees Celsius. Think about that, 15 million degrees. The sun isn't just a ball of fire. It really is a complex structure with multiple layers. At the center of it is the core, where the nuclear fusion happens. Hydrogen is turned into helium, and this releases unimaginable energy. Surrounding that is the radiative zone, whose energy slowly moves outward over thousands of years. And finally, the convective zone, where hot plasma rises, cools, and sinks again, creating a constant motion of solar material. At the sun's heart, extreme pressure and temperature drive nuclear fusion, the process that powers the stars. Hydrogen atoms merge to form helium, which releases light and heat, which travel across space, which eventually reaches us, which, like I said before, serves as the fuel for all life on Earth. The sun's surface is far from calm. You'll find sunspots, which are darker, cooler regions that appear during cycles, and then there are solar flares. These are massive explosions of energy that can disrupt satellites and power grids here on Earth. And finally, solar prominences, which are gigantic arcs of glowing gas looping into space. The sun's outermost layer, the corona, shines beautifully during a total solar eclipse. It's incredibly hot, much hotter than the sun's surface, and its shimmering glow comes from charged particles and magnetic energy. The sun follows an 11-year cycle of activity. During a solar maximum, sunspots and solar storms are frequent, and during a solar minimum, the sun calms down, so to say, showing fewer sunspots. These cycles affect everything from our weather to our radio communications. When solar flares or massive ejections of plasma, called CMEs, hit Earth, they can cause serious problems. Satellites could lose signal, GPS can glitch out, and even power grids can be overloaded. Astronauts in space face higher levels of radiation during these solar storms. However, there is also a positive to these solar storms. If you ever looked out, you might have noticed a solar event if you're towards the north of the Earth. But anyway, these solar events also create a degree of beauty. When a charged particle collides with Earth's magnetic field, we get auroras, those stunning green and pink lights that show near the poles. This is the sun's energy made visible in our night skies, as I said before, with ejections from the sun. The sun's gravity holds all the planets in orbit. Its light fuels photosynthesis, which feeds plants, which eventually feeds all other life on Earth, right? And its warmth keeps our planet hospitable. Not too hot and not too degree of cold, which is due to our magnetic field surrounding the Earth building the atmosphere. Our sun is a G-type main sequence star. It's pretty average, but incredibly stable. Some stars, like one known as Betelgeuse, are over 1,000 times larger. Others, like red dwarfs, are much smaller. Yet, our sun's almost perfect size and brightness make it ideal for supporting life on our planet. The sun formed over 4.5 billion years ago, and this came about from a cloud of dust and gas. Today, in its main sequence stage, steadily fusing hydrogen into helium. In billions of years, it'll expand into a red giant, which means it might even engulf something like Mercury or Venus, eventually maybe even Earth. And then it will collapse into a white dwarf, So to recap, the sun gives life, warmth, and energy to our planet. It's structured in layers that work together to produce power through nuclear fusion, and its activity, from solar flares to auroras, connect us to the wider universe in fascinating ways. Thanks for watching and learning about our incredible star. If you enjoyed this video, don't forget to like, subscribe, and let me know in the comments what your favorite solar phenomenon is. Thanks again for watching. I'll see you guys in the next one.